Thanks everyone for joining us today. I'm Collin and I'm the Emerging Technology Professional Practice Lead here at ISACA. And joining me today to talk about their recently released article, Implementing Artificial Intelligence, Capabilities and Risk, is Assistant Professor for the University of Florida, Ivy Munoko. Ivy, thank you for joining me today.
Thank you for having me. I'm really excited to be part of this today.
Me as well. I'm really interested in AI, so I'm looking forward to this discussion as well. Before we get started, why don't you just give a little background about yourself for our audience?
Thanks. So I'm Ivy Munoko. I'm an assistant professor at University of Florida. I studied here last year as part of a recruitment exercise at University of Florida where they're trying to integrate artificial intelligence with different fields. So I am part of the accounting department, and I joined it so that I can be able to teach our growing professionals, well, our undergraduate students, on how artificial intelligence is transforming the accounting profession. So I'm really excited to be here to talk about how artificial intelligence can be used for both accounting and auditing fields.
Awesome.
Yeah.
Yeah, I'm excited for you to be here as well.
Right.
So there are many definitions of artificial intelligence that are floating around in the world. How would you define it?
Right. So people always, when they hear about artificial intelligence, they think about robots, right? Because of all the sci-fi movies we've been watching from the 80s. But artificial intelligence can come in very many different forms. I think the most common form of artificial intelligence that we engage in that is invisible is the AI that's embedded in our phone apps, right? So every day we are interacting with AI. If you're using Google Maps, trying to get direction from one place to another, there is an algorithm that's routing you from your current location to another location. If you are Googling for a particular product, there are algorithms out there in websites that are trying to collect your data and try to recommend to you the most probable product you will buy. It might not necessarily be the best product for you, but it's the most likely product that you would buy. And so there are all these algorithms that are invisible and that are embedded in so many different websites and apps that we are using that we have no idea about. So that's the most common form of AI. But the other types of AI that I think the programmers are more familiar with, the version of AI I want to say that the programmers are more familiar with, are the ones that we hard code, that we actually deliberately create to, for example, enhance a company's performance, to enable a company perhaps for project or forecast what they will achieve in a coming year. So there's so many different types of versions of AI that we engage in, those that are invisible to us that we have no idea about, and there are those that we are more deliberately engaging in and that we have knowledge that we are using. So in my mind, that's the different types of AI. But basically, AI, its definition is it's a type of software or technology that mimics our human cognitive skills. For me as a human being, I have the ability to speak, to hear, to think, and so we are seeing all these types of AI that are being created that have the same capabilities like we do have as humans. For example, the self-driving cars, they have the ability to see, they have machine vision. The chatbots that we have on our phones, Alexa and Siri, they have the ability to talk just like we as humans, right? So they have natural language processing capabilities. So basically, artificial intelligence is this technology that mimics our human cognitive skills that is embedded in all sorts of devices, some of which we're not even aware of.
So why is it so important to understand the differences between the types of intelligence, the roles, and embedded technologies that AI systems can offer us?
Right. So it's interesting that when we talk about AI, we just think about this blanket technology that it operates all similarly, right? But AI can be used in different ways. So, for example, a company can use an artificial intelligence system to perform an exercise or a task from beginning to end to end. Those are autonomous AI systems, right? So, for example, I saw an interesting video of Amazon using robots in their warehouses to move products from one location to another as part of their distribution, right? So those types of artificial intelligence systems that can work all on their own without human intervention are autonomous systems, right? And those systems have higher benefits, of course, for companies, but they tend to pose higher risks if they are operating all on their own without human supervision or intervention, right? But then there are other types of AI that are less autonomous. They're like augmenting. They're just helping human beings do their functions, and those are the ones that I talk about in my article. The assistive or the augmenting AI systems that have they pose less risks to humans, but then they also have less, sometimes they're not as efficient, or they're not as economically attractive to companies as the autonomous systems are. But we have these different types of systems, different levels of AI. And in my article, I talk about how it's important to determine what tasks are best for what types of artificial intelligence levels. So it's sometimes there are some tasks that are not lending themselves to autonomous systems. You may want a human being to be in the loop, right, of that process that you're automating. But there are some processes that, again, might be just purely manual, repetitive, or they might not require as high level of intelligence. And for those tasks, it might make sense to use more autonomous systems where there is less risk. So it's really important for companies to think about these things before they actually implement AI systems. And that's what I talk about in my article.
So, what are some of the ethical concerns involving AI data usage and algorithms with all of these different embedded technologies that AI systems are able to offer?
Yeah. So when we think about artificial intelligence, we always want to implement them, and we have an intended goal, right? There's an outcome we desire. For example, we may have an auditing firm that is trying to implement artificial intelligence to enhance the ability to analyze, for example, thousands of records very quickly for their audit client, right? So that's a noble or a good use of AI. However, that intention might of using AI might lead to other unintended consequences. So in my article, I highlight, for example, some things that may happen. So you might automate a highly manual process, which is good, and you might use an autonomous AI to do that. However, you might realize that maybe those people who are initially doing those manual processes are now deployed to different tasks, and they're required to perform maybe higher level thinking, and they're not yet trained, or they're not yet prepared to perform those higher levels of thinking that are required for their new roles, right? And so if you're not able to properly plan and intentionally map out your human resources to have the skills to grow as you delegate more and more to AI, you'll reach a point where you will have perhaps a big gap between what you desire for your organization versus the outcomes that you will get from implementing artificial intelligence. So there are these unintended consequences that occur in businesses, right? But even in the real world, just other companies, without spotlighting any company's name, the companies that have deployed, for example, chatbots to be able to engage with their customers. And we have found that those chatbots sometimes begin to learn from human beings unintentionally. And while they were supposed to become very respectful robots, or very respectful representatives of the company, we've seen chatbots that actually end up abusing customers or abusing the people they're engaging with, because they are learning from their previous interactions with other humans. So you can have unintended consequences where chatbots or artificial intelligence can learn negative traits, and they can begin to replicate these traits on a higher level, right? So it's really important to not only think about how you will use the AI, but it's good to continuously monitor that AI in deployment to see whether it's actually performing as you intended it to do.
That makes sense. Yeah, I could see AI getting out of hand.
Yes. We've seen it in the movies. Okay, I think some things we see in the movies are a little bit exaggerated, but I think if you read the media, there is a lot of examples of ways in which algorithms have been used, and you could see that indeed they aren't being as fair or as good as we had hoped them to be, right? So even in the space of hiring, right? There's a lot of recruitment algorithms that are being used to hire people, to make decisions on whether to hire or not a job applicant. And there are cases where there has been very clear decisions that can be explained by the algorithm, right? That it decided not to hire this person for certain reasons. However, when you look at those reasons, you can see that clearly these are not ethical reasons. But the algorithm is pretty much trying to replicate what it's seen in previous hires, right? So if previous hires, for example, were of a specific gender or age group, or projecting certain skill sets, the algorithm is trying to just mimic or replicate those previous applicants. And then what happens is that it just continues to perpetuate the same things that have happened in the past, which sometimes might not be the best. And so we've seen those ethical issues arising in the media. And you can, I mean, these are things that are in the news severally, right? Even algorithms that are making decision on amounts of loans that people can get. You can get an applicant that mirrors another, so two exact applicants, but just a minor tweak on a specific attribute of the person that's beyond even what you should consider on loan applications. And that becomes a significant change in the amounts that those two applicants are approved for. So there are very many different settings. I mean, I can go on and on, even in the judicial system. So there are these very good ideas out there, and we don't want to stifle them. We want them to continue. We want to use AI in all these different nice ways, but we have to figure out whether we want to have autonomous AI or just augmenting AI, right? So you want to figure out what level you want initially, and that should be based off a risk-based analysis, right? You need to figure out what the risks are, and you have to become a little bit more innovative and think about those unintended consequences, right? It's easy to figure out what you want to get, but it's harder to figure out what you don't want to get out of this algorithm when you're going to implement it. But it's really necessary to have the right teams in the room to make those decisions. And that's what some of the things that I touch upon in the short article and that I expand upon in a longer academic article that I published in 2020 around the ethical implications of using artificial intelligence.
And is that found on ISACA?
So what's found on ISACA is the condensed version. So what I do is whenever I publish my academic articles, they are out there. But then for those who are in academic institutions, it will be free because usually we have free library databases. But because they come at a cost, if you're not in the academia area, what I do is I try to translate those academic articles into more simplified and free for ISACA members. And you can basically get two of my articles, the one I released in 2021 and 2022 on your journal, and both of those touch on the ethics of AI.
Awesome. Well, if you haven't read those already, take a look at them. I'm sure they're awesome. But thank you. So let's move on.
Mhm.
So why is mechanical intelligence considered the most basic? And then why is empathetic intelligence the highest level?
Right. So I think the best way to illustrate this is if you think about a child, right? It's very easy for them to walk, right? After their first, I mean, hopefully within, I don't know, the 13th month, 14th month, you're hoping that your child is trying to make some movement towards being a good, being able to walk. That's really mechanical intelligence, being able to figure out what the next step is. And if you're given a bunch of rules or or you can figure out a bunch of rules on how to achieve something step by step, then that's something that's purely based off mechanical intelligence. And that's very simple for even children to do. If you give them steps to build a toy, they can build that toy on their own, given those rules. And that's the same thing with mechanical intelligence in an artificial intelligence area, is if you can be able to build lines of code or scripts that can clearly enable an algorithm achieve its goal or achieve whatever you want it to do, then that's mechanical intelligence. And that's easier, as I said, to achieve. But then think about yourself, right? As a human being, the highest level of intelligence that we have that differentiates us from other animals is our emotional intelligence, right? Our ability to interact with other people, to be able to pick up on those cues, right, that other people might be giving off. And then we can be able to react and keep adjusting our behavior based off the cues we're getting from the world. And that's something that is increasingly harder to build algorithms to do, right? To be able to get an AI that exhibits emotional intelligence is something that we are all driving to achieve as AI researchers, right? You want your algorithm to just behave like a human being, but believe me, that is extremely difficult to do. And so, therefore, you have to think about if you're delegating a task to AI or if you're developing an algorithm that should interact with other humans, you need to consider whether it exhibits the necessary emotional intelligence to do that effectively. And so, in my article, I talk about having four levels of intelligence, which I draw from other academic literature. There is mechanical, analytical, intuitive, and then the highest is emotional intelligence. And that's where I think most of the roles that we take on, for example, as auditors, we require a lot of emotional intelligence. And that's what might make it a little bit difficult to implement AI on a large scale level to automate all the tasks that we do. So we shouldn't be worried that we might lose our jobs to AI, because a lot of what we do, I think, in many career fields requires emotional intelligence. And that's something that AI hasn't yet caught up 100% on.
Okay, good. Well, I guess how many years do you think until that does happen, where emotional or empathetic intelligence is out there?
I don't want to put my money on anything right now. I don't want to put a date on it because I'm going to be wrong, I'm sure. Maybe this exists in somebody's garage, right? Somebody have built this already and I have no clue. Or it might be something we will achieve. We might never fully achieve. Who really does know? But what I do know is there's a lot of money being poured towards achieving AI that exhibits exactly our skill sets, which is extremely, as I think, extremely difficult. The more and more you think about how complex our brains are, I mean, I enjoy reading judgment and decision making books. And if you figure out how we make our some split decisions, how quickly we arrive at these decisions, it's very impressive to know that the human brain is quite a small gadget that can achieve a lot. And so I really am not confident, like I can say any particular day, but I'm just still also not fully convinced that we have it right now. Although there's some people who claim that there exists AI at that level at the moment, but I don't think so myself. Yeah.
Okay. So, what are the differences between assertive, augmented, and autonomous AI roles?
Right. So basically, if you're thinking about an assistive AI, is one that you want to deploy, like think about Alexa's theory, right? You just want to be able to ask it something and it can assist you with some information that you will use as a person to make decisions, right? So it's just assisting you. So you can ask Alexa, hey Alexa, what's the weather today? And when if she says it's raining, then you can decide whether you go out or not, right? So it's just the chatbot is just assisting you to make a decision, right? But then in augmenting AI, you're having this is a setting where you and the AI are both making decisions in a particular task, right? An example in an auditing field is if you're performing an audit of a client, right? And maybe that client has uh 50,000 transactions that you want to review. So what you could do is you could deploy an AI, and there are already a auditing AI that exists that can audit the transactions and pick up those transactions that have a high risk score, and then that algorithm can present the highest risk transactions, or those that have the highest risk scores, to a human auditor who can review them and subsequently make a decision on those high risk transactions, whether to audit further or whether to issue a certain opinion based off what review the human has done. So in an augmenting setting, shortly, you're having a human and an AI working together to make a decision. And then ultimately, the autonomous AI is the one that I mentioned in the beginning, operates all on its own without any human intervention. So at this highest level, for example, self-driving cars are trying to achieve autonomous status, right? Where they can ride on the road without any human intervention. And so these are the three different levels that you need to be very aware of, and especially when you're implementing AI and figuring out whether you want one level in preference to another. So there's assistive, augmenting, and autonomous AI.
Awesome. So, why is it so important to establish how accountability will be enforced with the implementations of AI systems? And how can that accountability be enforced?
Right. So this is something that is currently a hot topic in research. A lot of, and not just academic research, there are a lot of institutions. For example, in accounting, there's the International Ethics Standard Board of Accountants, the ISPA. There are many other boards, ethic boards that are out there that are looking into establishing frameworks for accountability for AI. And basically, the challenge here is that you're having an autonomous, for example, algorithm operating and performing a task. And the question is, who would be accountable if something goes wrong? Think about the self driving cars. Who would be accountable if there is an accident, right? Would it be the person who bought the vehicle? Would it be the person who built the vehicle? Would it be the road on which the car is on? Like, who would be accountable for an accident, for example, that occurs on a road by a self-driving car. So these are the that's just an example. So this is the question that's being posed in different fields in accounting as well, and in I guess technologies. It's very hard, right? Should it be the third party who developed the software? Should it be the user of the software? Does the user of the software even have the capability to mitigate these risks? And so being able to assign accountability for AI across the different parties is something that is complicated, and it's something that's also currently being discussed, and there are numerous frameworks out there that attempt to address these types of issues. But again, as you require more and more case studies, you require more and more situations to be able to tease out the different complexities of using artificial intelligence in an augmented setting specifically.
You may or may not have an opinion on this, but I guess what do you think? What do you think is the right way when using these autonomous AIs? Who do you think is responsible, or what do you think is responsible in that situation with the self-driving cars, for instance?
Yeah, it is difficult because again, it's like a judge, right? You have to listen to the case, you have to look at the situation, and in one way two cases might look exactly the same, but just because there's a small tweak in it, then it goes the other different way than the other case. And so I think it's so context specific that it requires enough brains on this specific area, right? We need a lot of people thinking about it. We need the users thinking about this issue, right? Everybody who is deploying or using AI should be thinking about accountability and what are the challenge unintended consequences that occur, right? And I think especially the regulators need to work very closely with the people who are the firms that are deploying AI. The regulator should also work with the technology firms very closely to be able to clearly create regulation that is very applicable, right? Regulation that is based off case studies and observation. So I think this is something I cannot really say who should be accountable. I feel like we all need to be accountable. We all need to be part of this research, or this addressing this question on assigning accountability for autonomous algorithms, especially if we are deploying them in our firms and if we are regulating areas where there is high deployment of artificial intelligence.
Is there like a platform that people who are researching AI and doing AI and creating the algorithms, they all are working together so that, there is accountability, and, there isn't, uh, I guess, AI going kind of sideways and, putting malicious code that could do, who knows what in it?
Right. So I know in Europe there's a growing not even interest, attention on artificial intelligence, and there are a good number. The EU has come up with I think some guidelines that I don't know if they're yet enforced, but they have very clear guidelines on AI and accountability, especially for the developers. And I also know, like for example, ACM, Decision of Computer Machinery, I believe is ACM. I don't know what the full the full word is, but ACM basically have also their own codes that they have for developers, right, to guide them on what they need to do and their level of accountability as developers. They cannot just develop and deploy and walk away, right? So there are all these bodies that are working towards this. So I was just in another panel and we were talking about the fact that there's so many frameworks. There's a framework at every level. Like there are frameworks that are being done on the universal level, frameworks being done by governments, frameworks being done by IT people, frameworks being even developed by firms. Like there's so many frameworks out there. If you Google accountability and AI, you'll probably get a lot of good pop-up results as a result of that. But in short, I think we need more and more. I don't think we can say that they're enough or we should centralize this. I feel like we need to all be thinking about accountability on a very granular level. And I think that's what we are achieving right now. What we are seeing, everybody is there is discourse around AI and its ethical or unintended consequences on very many different levels and fields, which is a good thing.
Can AI learn, I guess, once it's out there, if they're with all these frameworks, can it learn how, uh, I guess, learn accountability, but can it also learn is something right or wrong, or is that something you have to program, like, okay, this is right, this is wrong, and avoid these certain scenarios they could do, I guess.
Yes. So this is again another very hot thing that is going on right now. Traditionally, when you were building an algorithm, say for example, I'm building an algorithm to predict the weather, right? To predict whether or to determine whether that algorithm is doing good, we look at its accuracy scores, right? Whether today it predicted it'll rain, and tomorrow they predicted there'll be sunshine and there's sunshine. Like that's its accuracy, right? So basically before I want to say 10 years ago, the focus was on building algorithms that have high accuracy. That was the goal. Are you accurate? But the other aspect that now we're becoming increasingly aware of is that we need to establish more goals and accuracy. Is it being fair in its decisions? And what is fair, right? How can you determine fairness? Even us as humans are struggling with fairness. We have referees in games and we still say this is unfair. Both sides will say this is unfair refereeing. But at the end of the day, we're struggling with defining fair as well in research, in academic research. And I think fair is something that means everybody has access. And how can we determine everybody has access to AI, or AI is giving fair, if it's being put in a judicial situation, for example, that it's issuing fair decisions, right? If it's, for example, approving loans, that it's doing so in a fair way. What is fairness in that setting? And how can we establish those goals for an algorithm? That's again another very hot research area, and I'm glad that you brought that up because it's something that I've been talking about as well with my research colleagues this week on how we can continue to define goals beyond accuracy for algorithms so that we can evaluate them on them being socially responsible as well. They're not part of society, but they need to be socially responsible because they're being deployed in a society and they might not have emotional intelligence. So, how can we embed those goals for algorithms in our code? Is something again that we are struggling with as researchers, but it's good that it's being discussed and people are looking into it.
Yeah, very important. So besides all that, I guess, what are some of the inherent challenges that AI technologies are facing today?
I guess challenges many years ago, I was still very young, but from what my reading is that the challenges used to be around having computing power, and that's sort of being overcome more and more now with increased computing speeds, right? And so our problems are moving towards a different type of problem, the data that informs the algorithms. So algorithms learn from data. Let me put it that way. Most algorithms do learn from data, right? And what data are they learning from, right? So, for example, for an algorithm to predict the future weather, right, what the weather will be tomorrow, it needs to look at the weather for the last maybe 100 days, for example, right? So if by looking at the last 100 days, that data it's using is complete, it's accurate, then that enhances the ability of it to predict accurately the future, right? But if the data is incomplete, it's inaccurate, or it doesn't represent well what actually happened, that will impact its future predictability, right? The future predictions. And so the issue here is that many situations we are trying to use or deploy AI without enough data or complete data or representative data. And so this actually is impacting the predictions of our algorithms, or the efficiency or effectiveness of these algorithms that we're planning to use. And so at the end of the day, I think data is becoming a hot topic that we are having. We're realizing most of the situations where we were relying on algorithms, the data it was using was not representative, and there ends up being unintended consequences of that. And so that's just, I think for me, when I think about it right now, data is really one of those big things that we are all struggling with. Where do we get the data, and how can we make the data representative so that it can make accurate predictions?
Seems like that might be one of the most important things. Without data and without it being reliable, your AI is just trying its
Absolutely.
best.
Yeah. It's like a 50-50 coin toss. And the problem is that people are saying, for example, that the AI said this, so it's true, right? People are believing in the algorithms more than they're believing in the experts sometimes, and sometimes it's the other way. But I'm more worried about the cases where people are just blindly following the algorithms or blindly are taking on the suggestions of the algorithms and AI without implementing any critical thinking of it. And that is I believe a bit of a risk.
Yeah. Okay. So, can you describe the close fit that you write is needed between the task requirements, the AI's current abilities, and the AI's roles?
Right. And so this just hits on to that again, that requirement for us to really think before we use. So we do have, here you have this fancy server, here you have this cool data, and you're thinking, okay, maybe let's build an algorithm here that can predict, for example, loans, right? We have all these past loans that have been issued out to our customers. We have this server. Let's use this algorithm to just predict and decide whom we should give loans to in the future because we already have default rates, for example. So as a company, we say, hey, let's deploy this AI to do so, and let's walk away. Let's not. We don't even need to man this AI. Let it just do everything for us. So in that situation, you need to think about what the risks are and being able to match the intelligence required for that task, right? There's only the hard information you have. Is that sufficient, right? Is there other soft information that, for example, a loan officer collects, right, by interacting with a customer that will be lost when we just deploy an algorithm in place of that loan officer, right? So these are the things that in every situation we need to think about when we are thinking about implementing AI. That close fit between what that task requires, right? The intelligence that we currently have within our algorithms or the capability of AI to perform those tasks. And then lastly, the role that you'll finally assign AI, right? So in the case where the risks are high, where there is need for other soft information that the human needs to collect beyond the hard information that the algorithms use, in that situation, you might actually want to use an augmenting an AI that works hand in hand with the human versus one that is autonomous working on its own. So again, just stepping back and performing a risk analysis and being able to determine from your risk analysis what's the level of intelligence required for the task, whether AI meets that level of intelligence, and then ultimately then deciding based off those two criteria whether you will assign a specific role to AI: assistive, augmenting, or autonomous.
So, before we close out, is there anything else that you'd like to mention to our audience?
No, I'm really excited. I'm so grateful you brought up some great questions today. And I just want to point them back to the articles, the 2021 article and the 2022 article. I feel like the 2022 was building off the 2021. So just going back and reading both of those, I believe would be a good way to just sort of tie all the things that we have talked about today together. And I'm so grateful that you gave me this opportunity. I'm really grateful to have this platform to share my research.
Yeah, I think AI is so cool. It definitely makes me a little nervous, and I hope everybody that is doing it and writing it and researching it, it stays good and it doesn't get out of hand. What is a normal AI like a basic like mechanical AI? Like how many lines of code is that used to like run? Is it like a ton or is it like
So it again depends on the task, right? And I think there's this overlap, right? There's this technology that's very common, like many firms are applying it now, called robotic process automation. So this type of automation is basically automating mechanical, like repetitive tasks in businesses, and actually does not require AI. So, for example, if every day an a accounts payable professional receives an email with invoices, right, from vendors. And what they do is they open the invoices via email. They open the email with the invoices. They download the PDF of the invoice. They upload the data that's in that invoice into the ERP system that the company has. If they're doing that every day, that's a very mechanical, repetitive task that robotic process automation does. So we don't even need AI per se to do mechanical intelligence tasks. Robotic process automation does that very swiftly and easily. However, AI, when you come to, as I said, there are four levels: is mechanical intelligence, it is analytical intelligence. So when you move from mechanical to analytical intelligence, then at the analytical intelligence level, you can have tasks there that really lend themselves to AI. For example, I gave you the example of using AI to be able to analyze transactions and pick up those transactions with high risk scores, like those that are potentially fraudulent, for example. We have AI that does that right now. And those are, if you want to say lines of code, it really does depend on what you're doing. But the good thing is that there's currently a lot of pre-built AI platforms that exist, or AI code that exists that people can easily deploy. In fact, I teach a no code course where you can learn AI without any coding. And so that's a way in which firms can quickly, just as I guess your goal is to, you're asking me, can we quickly learn how to build AI? And the answer is yes. You don't have to even code. There's software already that exists that can do these things for you. You might cloud-based platforms that you just need to subscribe into.
Awesome. I'm probably going to reach out to you so I can get some information on that because I'm totally interested.
I'm grateful for that.
So Ivy, you and I could probably talk about this stuff all day, but unfortunately that's all the time that we have left. Thank you again for taking the time to chat with me. I really appreciate it. And if you haven't yet and you want to read Ivy's full article, which I highly suggest doing as it is very informational and interesting, click on the link in the description below. Again, my name is Collin Better, and thank you guys for tuning in.